Hello, teachers of ECLPs. I hope that you are okay everywhere you are. And as you see me, I'm a mathematics teacher. We are going to continue for learning our subject mathematics by using the online class. Then, the lesson concern with limits of functions. Teachers, see me clearly. The lesson title we have here is what you call limits of functions. And I'm sure before going in your internship activities, we started this lesson together. Then, as you see, the unit lesson title concerned with the limits of a functioning, the first thing to do here, we try to get a general meaning of our lesson title. What is a limit of a function? Teachers, limit of function, it is like the end point of a function or maximum value of your given function. Then to define this unit title clearly, let's use an example. For example, when you have a limit of a function f of x, where x approach to a value a, and this limit equal to what? Simply, teachers, when you have a question like that one, we ask you to find the limit of your given function f of x, where x approach to a value a. In other words, we ask you to find the maximum point of your given function f of x when it's equal to a. And to get that maximum point here, simply we use the techniques of replacing the value of x here, by a. Then to get that maximum value, it is like f of here you replace where there is x by a, f of a. Then here f of a become the limit of our given function. F of a here stand for the maximum value of your given function f of x, where x tend to be a. This f of a, this is what you call the limit of your given function f of x, where x approach to a. Then let us again use a clear example. When we ask this one to find the limit of your given function 5 out of x positive 5 again, where x approach to 3. Teachers, see me clearly here. We ask you to find the limits. I'm sure every teachers of ECLP, he or she is able to use this abbreviation LIM to denote limits in mathematics. Limits, this word limit again is followed by a function. Limit of this ratio function where x approach to 3, it is like what is the maximum value of my given function where x equal to 3. Simply, we replace where there is x by 3. You get 5 out of 3, then positive 5. You get 5 out of 8. What is the meaning of this 5 out of 8? As you see here, 5 out of 8, this is the maximum point or maximum value, this 5 out of 8. maximum value of my given function f of x here, where x approach to 3. This 5 out of 8 as a result stand for the limit of your given function. Then, as a third example, you can take this one. The limit x approach to how many? X approach to 4 of the cubic root. Cubic root of x then positive 4. Teachers, see me clearly. We have a question like that one. The limit of your given function, as you see clearly, my given function is expressed by using the radical form. This is what we call irrational function. Then we ask you to find the limit of your given function where x approach to 4. It is like to find the maximum value of my given function here where x equal to 4. Simply, you replace where there is x by 4, you get the cubic root of 4 positive 4. This is the same as the cubic root of 8. Then the cubic root of 8 equal to how many? Equal to 2. How to get 2? You get 8, you express 8 in power form, then 8 equal to how many? Equal to 2 power 3. Then it is possible to simplify 3 by another 3 here in radical form. Then you still remaining with 2 only. Here, teachers, as a 2 here, the answer 2 we get here stand for the maximum value of my given irrational function where x approach 4. This is what we call the limit again. The limit of our given function is 2, where our given function x tend to be 4. Then, teachers, I'm sure we make a good revision about this lesson of limit of function. And I hope that everyone gets a new idea or a new meaning for the limit of a function. Today, teachers, we are going to focus on the sub-lesson of this one. It is like the limit concerning indeterminate form. The limits involving indeterminate form. Limits of functions. Then with limit of functions with indeterminate cases. It is like a sub-lesson of today. How to deal with limits involving indeterminate form. Here, teachers, the question to ask here about our sub-lesson concerning what is indeterminate form. Then in mathematics, something is called to be indeterminate form are those mathematical expression without a specified meaning. Mathematics expression without the clear meaning, without specified meaning. This is why we call those form to be indeterminate form. As a teachers, to introduce my sub-lesson here, teachers, let me to use an activity so that you can understand clearly the meaning of indeterminate form. Then introductory activity. I'm going to begin my sub-lesson by using the introductory activity. When you have a question like this one, first one, we have a question like find limits where x approach to 1 of which function? x square, -1 out of x, -1 again. Teachers, see me clearly again, see the given task here. We have this equation. Find the limits of our given function here where x approach to 1 or where x equal to 1. Simply, the first thing here, teacher, to do when you have a kind of limit like this one, replace where there is x by the given value. Here, the given value is 1. We replace where there is x here. Here we have x squared. It is like 1 square. Then -1 out of x, 1 -1. As I know, teacher, here, x squared, 1 square again equal to 1. 1 -1 equal to 0. We get 0 out of 0. Teachers, see here clearly. After replacing in my given function, after replacing the value of x equal to 0 here, the result I get 0 out of 0. Teachers, imagine when you have nothing. You have nothing, then we ask to share nothing you have with again nothing. Try to analyze this mathematical expression. Teachers, as you see, you cannot share nothing with another things. This mathematical expression cannot have a meaning. This is why we call this one to be indeterminate form. I use IF to denote indeterminate form. Then, activity number 2. When you have again the limits, where x approach to infinity of x positive 1 out of again x positive 4. We have a kind of limit like that one. We ask you to find the maximum point of my given ratio function where again x approach to infinity. Here, the first thing to do, we replace infinity with the value in the place of x again. You get infinity positive 1 out of infinity positive 4. I replace infinity in the place of, I replace infinity in the place of x here. Teacher, to do this equation where x approach to infinity, teachers, the first thing to know, you must know the properties of infinity. As you say infinity positive a number, you get infinity. Again, infinity positive 4 again, you get again infinity. You have infinity out of infinity. The greatest number divided it by another greatest number. But don't forget, you don't know the meaning. You don't know the exact value of that greatest number. Don't say this one, infinity out of infinity equal to 1. No. Because you don't know the value of, you don't know the exact value of first infinity out of another second infinity. When we say infinity, simply it is like the greatest number exists, but you don't know its exact value. This is why we call this mathematical expression to be again indeterminate form, because this form in mathematics cannot has a meaning. Then the last one, it is like when we have number 3, when we have the limit again. Let us put a point about those activities. Limit approach to infinity of this difference between two kind of function. For x squared positive 2, this one, negative 2x. Teachers, see here clearly. As you see, our given function, it is like a difference between two kind of function. The first one, as you see, it is expressed in radical form. This one is equal to be ratio function because it is expressed by using radical form. As you see, the second function is simply, we have a one term to it. This is a polynomial function with one term is equal to be monomial. Then To find the value of our given function, to find the result it is like the maximum of your given function here, where it's approach to infinity. You must know again the properties of infinity, because here it's approach to infinity. Then to find the solution, you get a square root of 4 in fact of infinity square, then a positive 2 both under square root, then negative 2 times the infinity. As you see here, from properties of infinity, a number times infinity square equal to infinity. Infinity times a number 4 equal to infinity. Again, infinity positive 2 again, still remaining you infinity negative another infinity here. Teachers, you must know properties of infinity clearly. As I see here, teachers, I get infinity negative another infinity. Don't say that form to be equal to 0. No. That form cannot be equal to 0, because infinity negative infinity cannot has a meaning. We don't know the exact value of infinity, but what you know, infinity is the greatest number exists. Again, this infinity negative infinity, this is what you call indeterminate form. This operation in mathematics, infinity negative infinity, this operation in mathematics cannot has a meaning. Teachers, as you see from activity number 1, I replace in my given function x with 1, and I get this value 0 out of 0, and here at the second, infinity out of infinity, and at the third one I get infinity negative another infinity. Those are a good form of indeterminate form. As you see, I deal with my given limits when I replace x with the given value infinity, I meet with a barrier. Teachers, again, see here on your chalkboard clearly, as you see those 3 activities concern with limits involving indeterminate form. Then when we have when we meet with this barrier for finding the limit of a function, we are going to discuss the way of rejecting out those barriers, the way of rejecting out those indeterminate form, so that you can get a real answer. Then, let us again begin our sublesson of today. Limit of function involving indeterminate form. By after this introduction activity, let us define clearly what you call indeterminate form. Indeterminate form. Teachers, as I say for you, indeterminate form, those are mathematics expression which cannot has a specific meaning. There is no clear form, or there is no meaningful form about those mathematical expression. Then from your textbooks, we define a limit, we define indeterminate form as indeterminate form is a types of what? Types of mathematics expression. It is like types of expression with a limit, types of expression with a limit that is no evidence that is not evident by inspection. By inspection. This is how to define indeterminate form from your textbooks. We define indeterminate form as a types of expression with a limit that is not evidenced by inspection. Simply, teachers, those are mathematical expression with no specific meaning. A mathematical expression without a clear meaning. This is what you call indeterminate form. Then there are many and many types of indeterminate form. There are many or several types of indeterminate form. There are many, not one. Among those many, among those many types of indeterminate form, the first one, 0 out of 0. In mathematics, when we get 0 out of 0, then don't say 0 out of 0 equal to 1. No. How 0 with another 0 give you 1? This form in mathematics cannot have a clear meaning. This is why to call it to be in indeterminate form. With those form without a meaning. The second, infinity out of infinity. The third, infinity, negative another infinity. Then the fourth, 0 times infinity. This form again cannot have a clear meaning. Again, 0 power 0 cannot be equal to 1. Understand this theory from surd and indices. From surd and indices law, there is a statement which says that all numbers power 0 equal to 1, but exception 0. 0 power 0 cannot equal to 1. 0 power 0 is a kind of expression which cannot have a meaning in mathematics. This 0 power 0 is said to be indeterminate form. After 0 power 0, there is 0 power 0. Again, infinity power infinity. After infinity power infinity, there is 1 again power infinity. Those are many types of indeterminate form. During your lesson of today, we are going to deal with the limits involving those kind of indeterminate form, but we deal with 3 cases in this lesson. In our lesson of today, we will study only 3 forms. We are going to discuss the limits involving 3 forms. The limit of function involving 0 out of 0. After this one, the limit of function involving infinity out of infinity. The last one, limit of function involving infinity negative infinity. Let us make those 3 cases by using an example so that everything should be clear for everyone, teachers. Then I say to you to follow me clearly. Then, teachers, as you see, we are going to begin with the first case. First case, we can say first case or yes, the case of okay. First case of infinity out of first case of 0 out of 0. This is what we call indeterminate form. Teachers, we are going to discuss it together. When you deal with finding the limit of a function, and you meet with this barrier, and you meet with this an obstacle, or you meet with this indeterminate form, how you can reject out this barrier, how you can reject out this indeterminate form, so that you can get the clear value of your given function. Let us deal with an example number 1. Example: we ask you to find the limit of your given function, which function x squared, then negative 4 out of x negative 2, where x approach to 2. Teachers, follow me here. Suppose you are in your national examination and you meet with a kind of a question like that one. How you make it clear? The first techniques for limit, as you know, limit of function, it is like a maximum value of your given function or highest value of your given function. As you see here, we have a kind of a ratio function. We ask you to find what is the maximum value of our given ratio function, this one where x approach to 2. Then teachers, to find the limit of my given function, directly I replace where there is x by 2 in my given function. Then I do like this one. I get 2 power 2 negative 4 out of 2 negative 2 again. Teachers, as you see here, 2 power 4, 2 power 2 equal to 4. Here I still remaining with 2 power 2 equal to 4, negative another 4, out of 2, negative another 2. I get the final one is 0 out of 0. This 0 out of 0 is what we call indeterminate form. This form cannot have mathematical meaning, teachers. Hear me clearly. I have a question like this one and I deal with it after, in the place of getting the final result, I get a barrier. I get an obstacle like this one. And this obstacle, you cannot say this one to be the maximum, the limit. This one cannot be the maximum value of my given function, because this form cannot has a meaning in mathematics. Then I'm going to find the way for rejecting out this indeterminate form, so that I can get the clear value of my given function. I'm going to find the way of rejecting this barrier, so that I can get the real value as the limit of our given function. Then to reject or to remove, we can use it to reject or to remove out. To remove out this barrier 0 out of 0, to remove out this indeterminate form, we are going to apply the techniques of factorization, so that I can remove this form in the process of getting the limit of our given function. Then to remove this barrier 0 out of 0, we apply techniques called the factorization. Then teachers, I'm going to apply this factorization process so that I can move this barrier. I can move this indeterminate form. And I ask you to see me clearly, teachers. Then the limit, the question we have the limit where it's approached to 2 of x square negative 4 out of x negative 2. Teacher, see me clearly, because I replace the value of x by 2 here at the first, I meet with a barrier 0 out of 0. I'm going to apply factorization so that I can reject out this indeterminate form. As I see here clearly, teachers, our given ratio function composed with a ratio between two polynomial functions. See here clearly, teachers, only the numerator of our given function. The numerator of our given function is somehow it is like a compound factors. As you see, my numerator x square negative 4, it is like a big compound factor. I'm going to find the way for finding another new simple factors in my given big compound factor. See me again clearly. As you see, this x square negative 4, it is like x negative 2, both in factors x positive 2. Teachers, the product of those two simple factors give us you this big factor out of x again negative 2. Then flow teachers, flow me clearly. As you see, my given function becomes this one. Then the limits where x approaches to 2 of your x square negative 4 out of x negative 2. This is the same as the limits. Then I decompose my given big factor into the small factors. It is like the limit of this one where x approaches to 2 of x negative 2 in factor of x positive 2, then above out of x negative 2. As you see here, teachers, on numerator, I get a product of two simple factors. This one times this one, then out of this one. As you see me clearly, this factor, x negative 2, is the same as this one. Then I can apply the techniques called factorization. I can simplify this one and this one. Then I get this one, the limits x approach to 2, I still remaining with x positive 2 only. As you see, that barrier here already is removed. I reject out my given barrier here. You replace directly the value of x here. The value of x equal to 2, replace where there is x by 2. You still remaining with 2, positive another 2, then the final answer equal to 2. Teachers, as you see, the maximum value now, the limit of our given function equal to 4. As you see, when I'm here, I meet with a barrier. A barrier. This 0 out of 0. An obstacle. This obstacle cannot help me to get the real number like 4 there. I find the process of rejecting out this indeterminate form in the process of getting the exact value, the limit of our given function. As you see here, the limit of our given function is equal to 4. Now we can conclude as the limits where x approaches to 2 of your given function x square negative 4, then out of x negative 2. Teachers, as you see, at the first time I meet with an obstacle, but I find the process of rejecting this obstacle so that I can get the correct limit. Then the limit of our given function where x approach to 2 equal to 4 exactly. This 4 equal to maximum point of my given function here, where it's approach to 2. Teachers, I am sure that everything here is understandable. For example, number 1. Even we meet with a barrier of indeterminate form, then we find the process of rejecting out that indeterminate form. Then let us deal with the second example. When you have a question like that one, maybe in your national examination there is a question like this one. Find the limits where x approach to 2 of, not to 2, where x approach to 4 of your given function, square root of x negative 3, this one, then negative 1 out of x negative 4. Teachers, see me clearly. We ask to deal with this one. What is the maximum value of my given function where x equal to 4? Directly replace where there is x by 4. You get how many? It is like square root of 4 negative 1. Square root of 4 negative 3. I replace where there is x by 4 here. Then negative 1 out of x by 4. 4 negative 4. You get how many? Square root of 4 negative 3 equal to 1. Square root of 1 again 1. You get 1 negative 1 out of 4 negative 4. Again, you get 0 out of 0. This form cannot have a meaning in mathematics. This is what you call indeterminate IF. Indeterminate form. I meet with a barrier again, teachers. Then I'm going to find a way for rejecting out this barrier so that I can get the clear limit of my given function. Then, which process I can use to get exact value of our given limit? Here, teachers, as you see, there is the presence of radical form in my given function. Here, the techniques of factorizing cannot be possible. You can find other techniques for removing this radical form. I'm sure, as you know, the techniques of removing radical form in your given function. To remove a radical form in the given function, simply you apply the techniques called the conjugate. This is why I'm going to apply conjugate so that I can remove this radical form. I can use a conjugate as a result of removing these barriers of indeterminate form. Then to remove, we say to remove or to reject out this barrier indeterminate form. This barrier 0 out of 0 indeterminate form. Here we cannot apply factorization because there is a presence of radical form. Here we apply what? We apply the techniques called the conjugate. Conjugate. The process of conjugate. This word in mathematics, teacher. When you understand the conjugate for radical form, especially understand a good way of removing the radical form. Then, flow me clearly, teachers, the limits where x approach to 4 of the given function x negative 3 of negative again 1, both out of x negative 4, I replace here with the value of x. I replace x by 4, I get this barriers. Then I want the way of rejecting out this barrier by applying the techniques of conjugate. This is the same as limit x negative 4, limit of my given function where x approach to 4 of this function. As you see, I'm going to apply conjugate of radical 4. I'm going to apply conjugate. The first one, we have x negative 3 in radical form negative 1. This factor, I'm going to multiply the conjugate of this factor, teachers. See me clearly. The conjugate of this factor. To find the conjugate of this one, simply you change the sign here inside. Then times the square root of x negative 3 again, then positive 1. As you see, this factor is a conjugate of this one. I multiply conjugate both sides, above and below. Then out of x negative 4, in factor of conjugate of again, x negative 3, then positive 1. Teachers, as you see me clearly, nothing changed. Because on my given equation here, I multiply with this factor above, and I multiply again with the same factor below. Then, the simple way of getting the result here, teachers, we can use what? The techniques of multiplying conjugate factor. Teachers, return back on the topic called to be sad and indices. From senior 2, I mean, the senior 2, there is a topic concerned with radical form, sad form. When we have a square root of a number a, positive square root of a number b, square root of a number a positive, another square root of a number b, both in factor form. Then times its conjugate. The conjugate of this one, you change the sign plus positive into negative. You get square root of a negative square root of b. Then when you have this factor times its conjugate, simply in place of multiplying each one by everyone here, you can use this one. This is equal to a square root of a square, then negative square root of b again, both square. Simply we still remaining with a negative b only. This is why this one, to multiply this factor with its conjugate, in place of losing my time by multiplying everyone by everyone, I take this one. This must be equal to the limit where x approach to 4 of what? Of square root of x negative 3. This one square alone, then negative 1 again square alone. I get the product of those factors simply. Then, or if you want, if you have a time, try to multiply everyone with everyone, you will get the same result. No problem. Then out of x negative 4, in factor of x negative 3, both under square root, then positive 1. Then we still remaining with what here? We still remaining with the limits x approach to what? X approach to 4. Then the result here, square root of x negative 3. This is equal to how many? Both square will still remaining This should be cancelled with this one, remaining with x negative 3, then negative 1, 1 square equal to 1, both out of x negative 4 in factor of square root of x negative 3, then both positive 1. Then, to get the final answer here, teachers, see me clearly. As you see here, we have x negative 3, negative 4. You get how many? You get x limit, x tend to be 2 of what? Of x negative 4. X negative 4, here we have x negative 3, negative 1. We get x negative 4 simply out of here. X negative 4 again, x negative 4, then in the factor of x negative 3 under root, then positive 1. As you see, this factor x negative 4, similar factor I can simplify. Then the final answer here, I still remaining with what? I still remaining with the limit x approach to 2 of what? Of 1. Here still remaining with 1 out of x negative 3, then both square root positive 1. This here. Teachers, as you see here, I try to reject my barrier here. I try to remove my barrier here so that I can get an exact value. Teachers, as you see me clearly here, we make a mistake. X tend to be 4. From my given question, look at here. X tend to be 4, not tend to be 2. Here, I make a mistake here. X tend to be 4, not 2. Again here, x tend to be 4. Then, as you see me, at this level here, I can replace the value of x here with my given equation so that for getting the real exact value as a result of rejecting our indeterminate form. Then I replace in my given function here where there is x by 4. Then we still remaining with 1 out of, in place of x here, put here 4, then negative 3, then positive 1. This is equal to how many? You get 4 negative 3 equal to 1. Then square root of 1 equal to 2. Square root of 1 may be equal to 1. You get 1 here positive, another 1. You get 1 out of 2 as a maximum value of your given function where x approach 4. Teachers, as you see, even I meet with this barrier of indeterminate form. Even I meet with the obstacle here of indeterminate form, I find the way of rejecting this form so that I can get the real limit of my given function. Teachers, understand these things. For limit involving indeterminate form, even you meet with those indeterminate form, let call those indeterminate form to be a barriers or to be an obstacle. You find the way of rejecting out those barriers so that you can get the real limit of your given function. Here I can say that the limit of my given function where x approach to 4, this limit equal to how many? Equal to 1 out of 2. This is what we call the maximum value of my given function where x equal to 4. Teachers, clearly, as you see, I meet with a barrier of indeterminate form, and I find the way for rejecting out that barrier of indeterminate form so that I can get the clear value of our given function. I mean, is it very, very, very clear and simple for the case of indeterminate form of 0 out of 0. Then we are going to deal with the second case of indeterminate form. The second, teachers, as you see, the process of helping teachers like you by using online class, somehow it becomes difficult. You help learners, but the learner you help cannot be around, so that you can face them face by face to solve a problem. Until now, I don't know where there is a challenge. But if we meet with a challenge, try to ask a question by using your online class. I will be there for helping you. Then now, as you see me, I get tired. Let's stop with these first taps of the form infinity. Let's stop here with this indeterminate form of 0 out of 0. Then next, like tomorrow, we will continue with another kind of form infinity out of another infinity. Then allow me to give you a kind of exercise to deal with. Then after, you will continue like tomorrow. Exercise. Evaluate. Evaluate. We ask you to evaluate the following. Evaluate the following limits. Evaluate the following limits. First quiz. It is like a quiz number 1. Hey, teacher, be serious. I put the marks you have here, I put it on your academic system. Only 15 marks. Deal with 15 marks. Then number A, we have the limits. Find the limits where x approach 1 with 1 negative square root of x, then out of x negative 1. Quiz number 1. Question number 1. Find the max. Find the limit of your given function. Which function? 1 negative square root of x out of x negative 1, where x approach to what? X approach to 1. Number B. Find the limits or evaluate the limits. This u here, our given function is expressed in terms of u. Don't be familiar with x always, teachers. No. A variable x should change. As here you can use u tend to be 0 of what? Of your given function as a ratio of 4 positive u, both in square root, then negative 2 out of what? Out of u. Here, teachers, your given function is expressed in terms of variable u. I say again, don't be familiar always with x only. X is a variable should change. Then number C, we have a limit where v, again I use a variable v, where v approach to 1 of this function. We have a 2v positive 1, both under square root. Then negative square root of 3, both out of v negative 1. Teachers, I say don't joke with those 3 questions. Everyone, 5 marks. 5 marks. Then number 2, 5 marks. Then number 3 again, 5 marks. You are going to work for 15 marks, but be ready, your marks you get here, I add it on your academic system. And I say, flowers, teachers, somehow I get tired. If you meet with an obstacle when you observe your video, please share your problem on WhatsApp group. We are there for helping you. And I say good night.